Because we are working with vectors and these are dot products over here, one of the things we can do is switch the positions of the dot products. Now, this is not something that you can do with a normal vector, but because these are with normal vector, this is not the commutative law, I mean, for vectors, but because this is a dot product of two vectors, it is possible because the dot product of two vectors is just a scalar, or it's a scalar product. So we can switch the directions around. And we can, by the commutative law, we can switch these to be before the magnitude of the vector. So we can say that u sub v will be equal to v dot x times u sub x. Oh, that's not a vector. Plus u, I'm sorry here, v dot y times u sub y. The reason for doing this is does not actually look important right now, but it's extremely important and will be useful to understand for later. Just keep it in your memory for operations that we'll be doing later. Let's now reach this part. We can also write an equation for u sub w as well. U sub w, we can say, is equal to the w dot x u sub x plus w dot y u sub y. Yeah, that looks really good. So let's erase this and see what we can actually get out of this. Let's sum everything that we have learned up to now. And a matrix. Give me a second to erase all of this here. I can erase that too. We can say that the vector u, oh, I missed the vector u at the beginning. I will put that in just now. The vector u is equal to u sub v in the v direction plus u sub w in the w direction, which is equal to the matrix multiplication of these two matrices over here, matrices, I should say. We can extend this a bit further. Let's make them less axis specific. So let's say that u now is equal to u sub 1 plus u sub 2, which is equal to we can call this, that might be a bit difficult. Let's